give us the privilege to welcome you first.
Okay.
Yes. Sonali ma'am.
Yes, sir. Namaskar to one and everyone. Thank you all of us for joining us for today's session. Myself, Sonali Deshpande, welcome you all, one and all, for today's sixth virtual. Uh, uh, this is our sixth virtual sky watching session from Earth to the Edge, a school student's guide to the sky. This week is also a very special week as we are celebrating our 104th birth anniversary celebration for our source of inspiration, Professor Rajendra Singh, which is fondly called as Rajju Bhaiya. And on behalf of PRSSE, it gives me an immense pleasure to warmly welcome you all for this virtual series. Uh, this series is also been conducted in association with NASNI, National Astronomy Network of IIPT, Indian Association of Physics Teachers. This series is designed to ignite curiosity and deepen scientific understanding and help young minds to connect to the classroom learnings with a vast and fantastic universe above us. Today's session is especially meaningful as we have with us a distinguished scientist whose work has directly contributed to the India's remarkable journey in space and exploration. May I now request our guiding light, Dr. Seema Ubare, Director of Professor Rajendra Singh Science Exploratory, to enlighten us with her thoughts. So handing over to Dr.
Thank you,
Seema
Sonali.
Ubare.
Thank you, Sonali. I'm Dr. Seema Ubale, and on behalf of Professor Rajendra Singh Science Exploratory, I welcome you, sir, for this online session. It is our great privilege to have you for today's lecture. And this is a special one because, as Sonali has told, that this week is being celebrated as the birth anniversary week of Professor Rajendra Singh, alias our beloved Rajju Bhaiya. And on this occasion, we have organized a couple of activities for the students of our exploratory. And these among these activities is one of the today's lecture. The activities which we had organized earlier, they were poster presentation competition, then there was an experiment challenge competition and a scientific storytelling competition. These are all to ignite the scientific temperament among the children. And today's lecture is also one of the such activity which gives the children to get involved in the cosmos and where to start for the astronomy, how to look into the sky, why look deeper, etc. So, I welcome you for today's lecture and uh, thank you once again for having uh, accepted our invitation for this lecture. So, with these words, I shall now hand over the podium or the mic over to you, sir. Thank you very much.
Thank you so
Well,
much, madam. Thank you so
before
much.
before going ahead for the lecture, let me introduce the audience to two personalities. Professor P.K. Ahluwalia, President, Central IPT, is also with us. We welcome you, sir, for this session. And yes, it is our immense pleasure to welcome a true pioneer in India's space endeavors, Shri Rajat Awasthi, sir, who is a senior scientist at ISRO's telemetry, tracking and command network, that is ISTRAC in Bangalore. With over 15 years of exemplary service, Shri Rajat has been at the heart of mission control for some of our nation's most prestigious space missions, including groundbreaking Mangalyaan Mars orbiter mission, Chandrayaan lunar explorations, the Indo-French Saral satellite, and the upcoming NISAR Indo-US collaboration. His pivotal contributions have earned him the prestigious ISRO Team Excellence Award, a national honor from the Department of Space, along with AMSET certificate for timely rescue of HAMSET, a first batch alumnus of Indian Institute of Space Science and Technology, that is IIST, having secured remarkable ranks in IIT, JEE and AIEEE. Shri Rajat combines technical brilliance with passion for mentorship. As a founder of online civil services learning community with over 10,000 members, he has guided numerous aspirants to success, including selections as subdivisional magistrate, deputy superintendent of police, and other key roles in Himachal Pradesh administrative services. His own journey, clearing UPSC prelims multiple times and reaching to the interview stage for Himachal Pradesh Administrative Services, exemplifies resilience and dedication. Today, Sri Rajat will share insights from the front lines of space explorations. Please join me in giving a warm welcome to Sri Rajat Avasthi, sir. Over to you, sir.
Thank you so much, sir, for such a lucid explanation of my journey in space sector and beyond. I'm really grateful for you people to invite me to this prestigious forum. And without wasting much time, I would like to get headlong into today's task. First of all, good evening, everyone. My name is Rajat Avasthi. I am working as a scientist in ISTRAC, Bangalore, since last 15 years. And I was an alumnus of the first batch of IIST, which is like NDA of ISRO. We were groomed by stalwarts like APJ Abdul Kalam, Professor Narlikar during our college days. And it gives me immense pleasure to address school students. And I'm really grateful to you people that you are acting as ambassadors of space science to the Indian public. As we all know, our government has set ambitious plans for expansion of space economy in India, and astrotourism is supposed to be one of the bulwarks of the plans that we have in mind. And to encourage people to participate in space economy, it is very important that people start looking at space with interest, with excitement, and with motivation. So today, as we sit here, the sun has already set, and for the most people, the day is over. Most people will tend to retreat indoors, turn on our artificial lights, and focus on our immediate surroundings. The question then arises, why should we look up when the world sleeps? The answer is a bit nuanced. The truth is that the sun, which is the provider of energy on this planet, our closest star, is also a bit of a bully. The sun's light is so bright that it blinds us to the rest of the universe. It creates a veil of ignorance that hides reality from us. It is only when the world sleeps and the lights go out that the curtain, the veil of ignorance, lifts. The next question that would interest the school kids is that, is there a time machine known to man? My answer would be in the affirmative. We look deeper in the night sky because night sky is the biggest time machine we have. Whenever we are looking at a galaxy or a nebula, we aren't just seeing space. We are seeing cosmic history. We are currently seeing the light that has traveled for millions of years just to hit our retina tonight. If we look deeper, we will find the secrets of our place in this vast cosmic ocean. It gives us a chance to look at the cosmic DNA. This is the reason why we should take time to look deeper into the sky at night. Today's lecture is going to be centered around a certain category of objects which we call as deep sky objects or DSOs. To give a brief introduction of them, to get um, familiar with the things we are talking about tonight. DSOs are basically fascinating celestial sites beyond our solar system. To further refine this whole definition of them, we should look into what are the exclusions of DSOs. What are not considered DSOs? Basically, anything inside the solar system like planets, sun, the moon, as well as individual stars outside and Milky Way galaxy as a whole are not included within the ambit of DSO. Then the question arises, what are DSOs? Basically, broadly speaking, we could categorize DSOs into three categories. One is star clusters, in which we could talk about open star clusters and globular star clusters. Then we come to star producing nurseries called nebulae, which are of three types: emission nebulae, reflection nebulae, and dark nebulae. Then we come to galaxies, which is our home in Milky Way galaxy. There are similar galaxies out there. Galaxies could be classified into spiral galaxies, barred galaxies, starburst galaxies, irregular galaxies, and interacting galaxies. So basically, DSOs are like the library of the universe. This library includes all the stories that are there to be known. The story of how we as human beings got here, star formation, elements in our blood, is written in some book in these dark object library. But before we start exploring this library, we need to understand the scale we are working with. Let us talk about the yardstick of the universe, which we know as the light year. When we talk about space, our normal rulers break down. Kilometers become useless. Using kilometers in space is like trying to measure the distance between Bengaluru and Delhi using vernier calipers. The numbers just get too cumbersome and too big to handle. To get out of this predicament, we use the term light year. Now, the term is a little bit confusing. Despite the suffix that is year, the term light year does not signify a unit of time but a unit of distance. It is the distance that light travels in one single year. As most of us know that light zaps along at nearly 3 lakh kilometers per second. In 1 year, that adds up to nearly 10 trillion kilometers. But the real magic of light year isn't just measuring distance. The real magic lies in the fact that it turns our telescopes into a time machine. When you are looking at the moon, you are peeping 1.3 seconds into the past. Similarly, when you look at the sun, you are seeing the sun as it was 8 minutes ago. If the sun were to vanish right now, we wouldn't know it for 8 minutes. When we look at the nearest star beyond the sun, Proxima Centauri, we are peeping into 4.2 years ago. So you can imagine the kind of insights this activity is giving us. So looking deeper into the night is literally time traveling. If we want to give an analogy to the school kids, imagine you have received a letter in your mailbox. The letter was written about 3 days ago. If you are reading it today, you are getting news of what happened 3 days ago, not today. Light is one such letter. It takes time to reach us and it delivers news from the past. It helps us peep into the very origins of the universe, which helps us to predict our future and understand our present in a better way. Now, coming back to the place where we live in, we all call our galaxy the Milky Way. We live in a sprawling metropolis of stars, which is called the Milky Way. For a long time, it was thought that the Milky Way was just a shapeless cloud. Is my voice lagging behind or something?
It's
Can
perfectly all
someone
right. It's perfectly all right. Don't worry. It's very clear.
Okay, looks like someone else in their own device is having some issues with the network. Okay, fine. We'll keep proceeding forward. So we are living like in a metro of stars called the Milky Way. For a long time, it was thought Milky Way was just a shapeless cloud. But modern astronomy has confirmed that we live in a barred spiral galaxy. It looks like a pinwheel in shape, with a rectangular bar of bright stars at the center. Talking of its size of this metro, it is colossal. It is almost 1 lakh light years across. If someone could travel at a speed of light, it would still take you 1 lakh years to cross it. And talking about our own place in this metro, sadly, we are not at the center of the universe as most human beings would like to think. In fact, the center is a chaotic, dangerous place packed with immense radiation and a supermassive black hole, Sagittarius A. We, on the other hand, live in a quiet suburb of this galaxy, which is nearly 26,000 light years from the core, tucked inside a minor structure called the Orion Arm. It is a safe, stable neighborhood, which is exactly what life needs to survive and thrive. It is basically something called as a Goldilocks zone, where all the conditions are just about optimum for life to survive. Talking about the population of this galaxy, it contains anywhere between 100 to 400 billion stars. Yes, that is true. Our sun is just one of them. Then we come to the downtown, the galactic center. It is a super dense black hole called Sagittarius A. In our own area, the suburbs that we talked about, we are located about halfway out from the center to the edge. And this place is not a stable place. The whole galaxy is spinning. In fact, our solar system orbits the center of the galaxy at about 8 lakh kilometers per hour. It takes us nearly 230 million years to make one full lap, which is the galactic year. Last time we were in the same spot, dinosaurs were just beginning to appear. Just imagine how much time has passed since then. We can imagine the Milky Way as a large dinner plate, and we are located about halfway between the center of the plate and the edge. If we look at the plate from the top, it looks like a spiral. If we look at it from edge on, it's thin and flat like a CD's edge. This flat shape is why we see as a line across the sky, because we are looking at it from within. Now we'll talk about the river of light, the Milky Way, in some more detail. If we were actually to go to a truly dark place, we will see a faint glowing band stretching across the sky. The ancient humans saw this, acknowledged it, and called it a river of light. But question arises, why does a spiral galaxy look like a river to us? For that, we'll have to imagine ourselves as a microscopic bug which is trapped inside a glass dinner plate. If we look up or down out of the plane of the plate, we will see very little glass. But if we look into the plane of the plate, sideways, we will come across the thickness of the plate, and a dense wall of glass will be visible. We are all inside this flat disk of the Milky Way galaxy. When we look into the dense plane of our galaxy, we see billions of distant stars blending together into a hazy glow. That glow is actually the body of our own galaxy, since we are looking at it from within. The edge on view is the galaxy edge because we are embedded inside the galactic plane. Apart from that, we also come across a great rift. We'll notice dark patches in the Milky Way, especially near the Cygnus and Sagittarius locations. These dark spots are not empty spaces, they are actually massive clouds of cold interstellar dust which are blocking the starlight behind them, almost like a silhouette. There is also seasonal variation in our observation of the Milky Way galaxy. We see the center of the galaxy, the brightest part, best during the summer months, that is around June and August. In winters, we look towards the outer edge, so this center becomes a little faint. Talking about cultural connection in Indian context and ancient context, different cultures have been mesmerized by the Milky Way galaxy and have given it different names. The Greeks and the Romans called it Via Lactea, which means road of milk. They believed that it was milk spilled by the goddess Hera. This later on evolved into to the English name called Milky Way. In India, it was called Akash Ganga, the Ganges of the sky. In fact, the Ganga that flows on earth is supposed to be a manifestation of this Akash Ganga, which was brought on earth by the mythical king Bhagirathi. Next, we come to star producing nurseries called the nebulae. Stars don't appear out of nowhere, they are born out of the nebulae. And their birthplace is spectacular clouds of gas and dust. The most famous example is the Orion Nebula, which is also called M42. More on this acronym M42 in some time. If we look at the constellation Orion, we see the famous hunter, his belt of three stars, a sword dangling from that belt. If we look closely, the middle star of that sword actually looks a little fuzzy. Now, that fuzzy little thing is not a individual star at all. It is a colossal factory of stars located nearly 1300 light years away. Inside this cloud, gravity is pulling dust and hydrogen gas together. As particles clump together, temperature rises, things get heated up, and eventually a nuclear fusion reaction is triggered. So, what we are seeing here is a cosmic nursery that is continuously producing stars. The bright stars in the center, the trapezium of the Orion, are newborns which are only a few million years old. So basically, the word nebula is derived from the Latin word which means cloud or fog. It is primarily composed of hydrogen, helium, and dust. The process of star formation goes something like this. Gravity collapses the cloud, which leads to an increase in pressure, which leads into an increase in temperature, and fusion reaction gets eventually ignited, and a star is born. If we talk about the colors that we can perceive from these regions, red or pink color is actually the glow of hydrogen gas which has been excited by UV light from nearby hot stars. If we see blue light, it is just like the sunlight scattering in our own blue sky. It is dust reflecting the light of blue stars. M42 is also very special in the sense that it is probably the only nebula you can see without a telescope, even from suburban skies. So, talking about analogy of a nebula in a layman's language, a nebula can be thought of as a storm rain-bearing cloud, but instead of raining water, this cloud rains stars. The Orion Nebula is so massive that it can create thousands of suns. Now we come to next category of DSOs, which are galaxies. We have already talked about our own Milky Way galaxy. Now let's go into our extended neighborhood. Our closest neighbor is the Andromeda galaxy, which is also called M31. It is like a big sister to our Milky Way galaxy. While the Milky Way galaxy has nearly 400 billion stars, Andromeda has nearly 1 trillion. So you can imagine the scale. It is the most distant object that you will be able to see with your naked eye. If you look at Andromeda galaxy, you are seeing light that has been traveling for 2.5 million years. So you are peeping into the past for more than 2.5 million years. Just think about that. When the light hitting your retina tonight left Andromeda, humans didn't exist. Woolly mammoths hadn't evolved yet. And Our ancestors were just early hominids in Africa. It is telling you a story when our present species wasn't even born. Another important thing about Andromeda galaxy is that it is eventually going to crash into us. In about 4.5 billion years from now, gravity, which is pulling Milky Way and Andromeda towards each other at nearly 110 kilometers per second, we will collide and merge into one giant elliptical galaxy. The diameter of Andromeda galaxy is more than twice the diameter of our own Milky Way. If we talk about visibility, in a dark sky region like Hanle or similar such region, it looks like a faint fuzzy oval, even visible with some humble binoculars if you want. Another important thing about galaxies is that galaxies generally don't hang out alone. They have local groups or sisterhoods. For example, our local group contains the galaxies Milky Way, Andromeda, and Triangulum Galaxy M33. These are the three big players in our local group of galaxies. So if the Milky Way was of the size of a CD, Andromeda would be probably twice as large, almost 8 feet away, while the other galaxies would be kilometers away. So that gives us the cosmic scale of proximity of Andromeda to Milky Way. Now we'll unravel the mystery behind the nomenclature, the acronyms you were using like M1, M31, or M42. In astronomy, you will constantly hear about names like M31, M42, etc. What does this M stand for? This is actually a very funny story. M stands for the word Messier. Charles Messier was a French astronomer in 1700s, and his job was to hunt comets. In those days, if you discovered a comet, you would become immortalized because of the comet, like Halley's comet, etc. It would bring you great glory and fame. So Messier was relentlessly hunting for comets, but instead he kept on bumping into irritating, annoying, fuzzy blobs in the sky that seemed like comets in the beginning, but didn't move. Every time he bumped into one, he got excited only to realize, oh, it's just another static cloud again. So, out of frustration and irritation, he created a catalog of objects to avoid while hunting for comets. He basically wrote down in his book, don't look at M1, it's not a comet. Don't look at M31, it's not a comet, etc. And ironically, today Messier is famous not because of the comets he spotted, but because of the non-comet catalog that he created. So his nuisance list has actually become the greatest list that amateur astronomers would like to know about. His catalog basically consists of almost 110 brightest, most beautiful deep sky objects known to man. And it is a perfect starting point for anyone who wants to get into amateur astronomy or stargazing. The catalog consists of a total of 110 objects numbered M1 to M110, and it contains a variety of objects. It's a mixed bag. It includes nebulae like M42 Orion. It also includes galaxies like M31 Andromeda Galaxy. It also includes star clusters like M45 the Pleiades, and even supernova remnants like M1 the Crab Nebulae. These things are, in fact, not only useful for amateur astronomers, they are also useful for scientists like me. We don't use amateur telescopes to peep into the sky and deep universe. We actually have our telescopes into orbits. I have controlled satellites like SAT, which is also called the PhD satellite. The data of Astros has helped so many people accomplish their PhDs. And Messier objects like the Crab Nebula, etc., are in fact used to calibrate the sensitive instruments on our satellite-based telescopes. That is the amount of utility Messier objects have. So the question comes, why should we start from Messier objects? For the simple reason that Messier was born somewhere in the 1700s, and the telescopes he was using at that time were probably equivalent to binoculars of today. If he could see these objects by telescopes of that time, today's students can actually identify these objects with even binoculars. So if you buy a telescope, don't start just by randomly looking for things. Start by trying to find all the Messier objects first. It is like an initiation ritual for any amateur astronomer. Some people also call it the Messier marathon. Once you identify all these objects, you will have a vantage point. You will have something to navigate by. In fact, some of these objects are also used in almanacs of star sensors that modern satellites use for inertial navigation. That is the amount of popularity Messier has achieved. So now we come to the fact that in case we want to observe all this phenomenon, where should we go? The good news is that you don't need a passport. You don't need to go to Hawaii. Don't need to go to Atacama Desert or a fancy location like that. In our own country, we have a great site called Hanle in Ladakh. Hanle is actually home to Indian Astronomical Observatory, which is operated by Indian Institute of Astrophysics. It is located at nearly 4,500 meters above sea level. To give you a perspective, that is actually higher than the base camp of Mount Everest. Now, because it is located at such a high altitude, it has several advantages for astronomers. For one, the layers of atmosphere are rarer because of the height factor. It is also in rain shadow area. It is a cold desert of Ladakh. That is why the air here is very dry. There is almost no moisture to blur the stars. There is no aberration problem. And this area is also very inhospitable in terms of weather, etc. So the area is sparsely populated. So we don't have the light pollution of cities over here. Looking at its astrotourism potential, Government of India has recently declared the area as India's first dark sky reserve. It has been acknowledged by Government of India, and it is a place where darkness is actually protected by law. It is also a unique model where tourism also helps the local community. The local villagers have been trained as astro ambassadors. They have telescopes in their homestays and they reduce their own lights at night to protect the observatory. Last time I checked, there was a footfall of nearly 50,000 people annually. Even if they are spending nearly, let's say, assume 10,000 rupees for a week stay, just imagine the contribution to the local GDP that it's bringing. So, Hanle, as we know, has been officially designated as a dark sky reserve and it spans nearly 1,000 square kilometers. I also remember that in 1962 war there was some debates in which people said that it is such an inhospitable place. Why do we even worry about it even if the Chinese have transgressed? So now we look at the utility of such places, the kind of value, economic value that they can add to our economy. It is also home to several international projects and especially Himalayan Chandra Telescope HCT. It is a 2-meter optical infrared telescope and is one of the highest observatories in the world. Apart from that, my own office, that is ISTRAC Bangalore, has a unit called Netra, which is all about space situational awareness. You might have heard about a term called Kessler syndrome. Sending satellites into low Earth orbit has become so mainstream. Every new university that comes up wants to launch its own satellite as a kind of advertisement. And therefore, there was a scientist in NASA called Kessler. He predicted that eventually the low Earth orbit region will get so overpopulated with satellites and debris that each particle of debris will collide into the other object and lead to a geometric progression of debris particles, eventually creating a Saturn ring-like structure of debris around the Earth, making future launches impossible. To prevent such a scenario, um, we have created a unit called Netra. It identifies if any debris particle or any dangerous particles, space particles are close to our operational satellites. And to do that, we need to place some telescopes for space situational awareness strategically throughout the length and breadth of our country. And one of them is supposed to come up in Ladakh near Hanle. And other one is probably going to be placed at Jidrangal in a place near my hometown, Dharamshala, Himachal Pradesh. So basically, these dark sky reserves are not only useful from the point of view of astrotourism, but also from a strategic point of view for keeping our space assets safe. To talk about the kind of quality that this place offers for stargazing, there is a scale called Bortle scale, which classifies sites according to the quality of darkness they provide. So class 1 is basically the darkest possible sky, and Hanle is class 1. So you can imagine the value it offers to astrotourists. Apart from that, Hanle also offers you almost 270 days of clear night skies per year, cloudless skies. So that is almost 70% of visibility in a year. Hanle is not alone in India. As we know that the Ladakh cold desert has its extension in Himachal Pradesh as well in form of Lahore Spiti cold desert. So there are sites like Spiti Valley, Kibber, Kaza regions in Himachal Pradesh. Then we have in central India, Pench Tiger Reserve, Madhya Pradesh, which is also international dark sky park. Apart from that, in South India, we have Kurg in Karnataka, and we have Mukteshwar in UK, Uttarakhand. So you can find any such location which is closest to your home, and you can try getting hands-on experience in one such dark sky observing area. But an important tip if you are planning to come to Hanle. If you ever visit Hanle, just remember one thing, that acclimatization to this high altitude observatory is non-negotiable. You cannot simply fly into Leh and drive into Hanle the next day. Even our soldiers of Indian Army, Mountain Battle Corps, etc., they are given mandatory acclimatization training for several weeks when they are deployed to these regions. So you would probably need a few days at least in Leh to adapt to the lower oxygen levels. If you don't do that, if you are impatient, then the only stars you'll see, sadly, would be the ones spinning in your head due to hypoxia. Finally, to wrap up today's lecture, I would want to give our students some practical toolkit. If you want to get into deep sky gazing, stargazing, astrophotography, astrotourism, you don't need $1 million observatory to enjoy the night sky. All you need is patience, the right place, and the right habits. Some tips. Firstly, you need to protect your night vision. We all know about rods and cones inside our eyes. It's the high school biology. Our eyes take about 20 to 30 minutes to fully chemically adapt to darkness, which is achieved by building up a chemical called rhodopsin. If you look at your phone screen or a white flashlight even for 1 second, you effectively reset that clock back to zero, and your eyes have to go back full circle 20 to 30 minutes again. So it's advisable to use red light because red light does not trigger the reset. Secondly, it's about Chanda Mama or the moon. The moon is a beautiful space object, but it is also emitter of the biggest natural light pollution. In fact, when we control our satellites, we have to be very careful of a phenomenon called moon intrusion. The brightness of the moon has the capacity of saturating our star sensors or causing problem with our instruments. So, if you want to go stargazing, you should plan your trip according to phases of the moon. New moon phase is probably the most beneficial. Thirdly, instead of straight away buying an expensive telescope, you should first start getting familiarized using a set of binoculars. Straight away jumping to telescope may not be that optimal. A pair of standard binoculars will actually help you see several of the Messier objects, which you can use as vantage points later on. And finally, we have several apps that could help you in your pursuit of skygazing. You could download apps like Stellarium or Starwalk. You could point it at the sky, learn about the constellations, then put the phone away and start identifying these structures with your own eyes. So before you begin your journey, always remember the following points. The red light rule. White light bleaches rhodopsin in the retina. Red light is less energetic and preserves it. The 20-minute rule. It is not instant. You need some patience. You have to sit in the dark and wait. Binoculars can be a good starting point before you graduate to telescopes. And the moon. The new moon, the sky is the darkest when the moon is not visible or sets early. So that could be an advantageous time to go stargazing. Finally, I would like to conclude by saying that the universe has several secrets that it has been waiting for humans to discover. It has been waiting for billions of years. All we have to do is turn off the lights, look up, let our eyes adapt, and start time traveling. Thank you so much. I hope you enjoyed the lecture, and I hope I was able to make it interesting, although I come from satellite operations area, but I did have some uh, interest in astronomy and also um, had some background in astronomy at college level. Uh, if there is any lacuna or problem in my lecture, I apologize for the same, and I hope you enjoyed it. And I would be looking forward to further association with your esteemed organization and students. Thank you so much.
Thank you, sir. It's been our pleasure and wonderful hearing from you about the deep sky objects and the light years from Andromeda Galaxy to Orion Nebula and all the way from the Milky Way. It's the history, the human evolutions that started from all the way down over there. Historic entry of Messier, and also you're the most important part that the dark sky tips for the beginners, where you have guided us for the do's and don'ts, how to plan your trips. And certainly it would be a it is really a very beneficial tips for all the amateur skygazer. I will now ask students to have any questions, inquiries. If you doubts they want, they can raise your hands and ask sir for the questions. Yes, students, do you have any queries or doubts here? We will entertain it for.
If you want to ask any information, any curiosity about our own satellites, which are working as space-borne telescopes, I would be happy to give you information which is available in public domain. How to measure light years? Light year is actually the distance traveled by light in a single year. So you can use your basic formulas of calculating distance based on speed and time. 1 year time is given, speed of light is known, and you'll get the distance traveled by light in 1 year. Red light is not very detrimental to rhodopsin. It has a longer wavelength, and even in your smartphones, you would have seen that these days we have blue light filters. So blue light is actually detrimental to our eyes, especially in the night. In fact, when psychiatrists talk about sleep hygiene, they ask you to stay away from blue light for nearly at least 30 minutes before you go to bed. Orion is probably a good start. Andromeda Galaxy is also a good one. For a career in space science, well, currently we only had our government agency ISRO, which was operating in space sector. But slowly we have a lot of startups. Some of my own batchmates have quit ISRO to create several startups like SatSure. Then we have Pixel. Even I've heard that Geo by Mr. Ambani, he's also planning to venture into the space sector. So you will have a lot of career options in the future in space sector. But if you currently want to become a scientist, there are three options. You can qualify IIT JEE exam, and probably you'll have a campus placement in ISRO easily if you qualify and do BTech from an IIT. Other thing is that if you get a good rank in JEE Advanced, you can join IIST, which is ISRO's own institute. Although there is not a guaranteed job like it was in our times, but still several people from IIST get placed as scientists in ISRO. And if you fail to qualify IIT JEE or you do not get admission at graduate level, undergraduate level to IIST, you can graduate from streams like ECE or computer science or mechanical, etc. And then you can write an exam called ICRB, which ISRO conducts for graduates. If you qualify that exam, you can become a scientist in ISRO. I do not have a specific prescription for binoculars, but any standard binoculars can help you identify at least some of the messier objects. GATE exam is for doing MTech from IITs or ISC Bangalore. Through GATE exam, I'm not sure whether I don't think by qualifying GATE exam you become eligible for joining in ISRO as a scientist. Uh, After graduation, there is only one option, that is ICRB exam. Light actually brings you information of events, what happened in the past. It gives you information about relationship of present celestial objects with each other, so that you can create patterns of behavior and predict what will happen in the future.
Okay, so with this note, we have come to the part. I would like Seema ma'am to have a few words.
Hello. Sir, it
Uh,
was really very wonderful lecture. Am I audible?
Yeah, thank you, ma'am.
Hello. It was really very
Yeah, ma'am,
wonderful
you are.
lecture. Pardon, sir?
Yeah, you are audible, loud and clear.
Thank you. Fine. Actually, you were telling about Hanle. Last year, I had been to Leh, and we could not go to Hanle, but we went to that Turtuk, and we had organized some sky gazing event from there. So, but
Oh, nice.
I could not find a dark space because there were a lot of lightings around. So the vehicle means the
Okay.
driver of the vehicle took us to a dark area, and we could see the sky very nicely from there. So it was wonderful experience, and I can imagine that what it must be at Hanley. So thank you very much for sharing the information. Now I take this opportunity. We have with us Professor P.K. Aluwalia, sir. So I would like, sir, you to say something about today's program, sir. Over to you, sir. Aluwalia,
Thank you
sir.
very much. Thank you, Ma'am Seema. I'm very happy to be part of today's lecture. And it was a pleasure to know that the today's honorable speaker comes from Himachal Pradesh. I am also sitting in Himachal Pradesh, Avasthi.
Oh,
I'm in
that's
Shimla
nice.
right now.
Oh, wow. You
Okay.
must be enjoying snowfall right now,
Uh,
sir.
Pardon?
You must be enjoying snowfall, fresh snowfall right now.
Oh, yes, there was wonderful snow. And today in the evening, there were clouds, and it was a wonderful set of pictures which we could see the play of light and clouds, mind boggling. The sky was on the fire, I would say. So, sky is always a wonderful place to observe physical phenomena, actually. There are so many things which keep on happening. Um, you can spend a full day sitting on the terrace watching clouds moving here and there. And then sometimes you can see on the distant mountains rain is coming and falling. You may be sitting in the sun, but maybe at a great distance you can see that, yeah, there is rainfall happening. And then the mist is very, very magnificent. The way it plays around during monsoon and also during winter, that is mesmerizing. I really liked your lecture. It was just wonderful. I think you had paced your lecture wonderfully, and you had kept the uh, various things very, very interestingly. It was very nice to know that as a beginner, we should first focus on Meissner objects. Meissner atlas actually is the best thing to do that. Shimla also has some wonderful, dark nights available at
Yeah, sir.
certain places. And
Yes.
we are very soon
Prospect
going to
is one.
have a planetarium also in Shimla.
Oh, that's
So,
heartening to know.
so Himachal is going to be on the planetarium map of India also very soon.
Very soon.
In Shimla, there is a place called Tara Devi. I don't know whether you have been there, Avasthi ji.
Yep, yes, yes.
Uh,
I know that, sir.
and there is a 360-degree view of the sky available from the top.
Yes,
Yeah.
yes.
But unfortunately, there is a floodlight there which doesn't let people see around. That has to be switched off actually if one wants to go do some sky watching there. And
Yeah, it's actually famous for that temple.
yes, yes, it is a very famous temple. And I think sometimes when you come to Himachal, please let us know, and we would love to arrange
Definitely,
some
sir.
lecture somewhere in Himachal. Which is your native place where you come there?
Sir, basically, I'm from Dharamshala in district Kangra.
Okay, okay, okay. So you after
But,
your
but I
schooling,
do have my schooling was done from Sacred Heart in Dharamshala, and
okay,
my 12th class was done from Delhi Kalka Public School.
okay. So you directly from 12th, you went into that Space Academy.
No, first I was in NIT Warangal after qualifying
Oh.
IIT AIEEE exam in the first attempt,
Mhm.
and in the second attempt I qualified IIT exam, and then I joined IIST directly from IIT Delhi Counseling.
Okay, okay, okay. That's wonderful. Great. And then I think you are very fortunate. You were saying that you could hear APJ Kalam coming and giving you lectures. And that was
Yeah.
before he became president or after he became president?
No, it was after he retired as a president. He was
Okay.
chancellor of our university
Yes,
until
yes,
his
yes.
unfortunate demise. And
Mhm.
we also had Professor Yashpal Sharma taking some lectures, who was the ex-chairman of UGC.
Yes, yes,
Professor
yes.
Narlikar, Professor Rodam Narsimha, several
Oh,
stalwart.
all luminaries of Indian space science.
Yes, sir.
So thank you very much. I think we will also love to have you in NASNI. It was in fact a program in collaboration with NASNI only. NASNI is our
Actually,
national.
I am in the WhatsApp group of Nasini. I'm not a formally member of it, but I would love to be one.
Actually, if you are a lover of physics, I would definitely say that please become our life member of Indian Association of Physics Teachers. I am the president
Sure,
currently, and
I would be
we
in touch.
are yes, yes, and we are very much keen. And let me also tell you, maybe you must be knowing about it. In the last 1 year, we had about 24 talks. Every month, we have 2 talks, Wednesday talks, we call them. And
Yeah,
a beautiful booklet has been brought out. You must have seen in that group also, which was Cosmic
yes, sir.
Conversations. And I think that was a
Yes, I
great
have.
attempt to
True.
uh, bring people very close to साइंस एंड द वंडर्स ऑफ स्काई सो थैंक यू वेरी मच
Yes,
रजत
sir.
जी मिलेंगे आपसे कभी है ना मौका मिलेगा तो मिलते हैं आपसे है
बिल्कुल,
ना
sir. I would be in touch with you.
यस यस okay thank you very much enjoyed your lecture and very well done students I really was very happy to listen to your questions sometimes these questions don't come from a mature audience also which you were asking that was
Thank
just
you.
great and that shows the kind of training you are getting at the
Exploratory,
this
sir.
exploratory
Exploratory.
of Professor Rajendra Singh ji's, who was a physics professor actually.
Memory.
And he was also Satsang Chalak of Rashtriya Swayamsevak Sangh.
Oh,
So it's
okay.
a great place. Rajat, if you get some time, do visit this exploratory also. It's a wonderful concept. And
सर आप भी
ma'am,
आइए सर
Seema,
आप
मैं भी
दोनों ही
आऊंगा
आइए
Definitely. We
Where is
will be
the
delighted to have all of
exploratory located?
you people at our exploratory, sir.
Yes,
Where is
yes,
it
and
located?
It's
it
at
is in
it
Nagpur.
is
Nagpur.
in Nagpur Nagpur
Okay, okay,
yes
ma'am.
sir
And
yeah we look forward to
and Govinda Lakhotia is a motivating force for me also to get into astronomy actually. So uh, I always feel inspired when I come to these programs. That gives me a kick of keeping myself doing something. Though I'm
Definitely,
retired,
definitely.
I retired in 2015, but I think these are
Definitely,
the
sir.
events which give
Your
me a lot of
experience
joy.
is more valuable and more will be a best of thing for us if you really visit at our exploratory.
So thank you once again, Prissy, I would call it, and Rajesh ji, Govinda ji, Seema ma'am, and today's host. Ma'am, thank you very much.
Thank you, sir.
yes
I
Thank you.
heartfully thank Avasti sir and Aluwalia sir that have taken time from their busy schedule and have graced up with their experiences and with the knowledge that they help those amateur skygazers and have given us one more ray of knowledge and more ray of light over it. Thank you very much. And with this,
Thank
I will take this session to the end, and we'll declare that the meeting has been over, officially over.
Okay.